Okay, this time we're going to discuss about quadratic functions of the form f of x is equal to ax raised to 2. Graph the function on one coordinate plane. So let us try to identify what is the difference on f of x is equal to x squared and that of g of x is equal to negative x squared. So we have here, if your x is negative 2, the value of the function is 4. If your x is negative 1, then your y is 1. If x is 0, your y is 0. If x is 1, then your y is 1. If x is 2, your y is 4. So we have here, g of x is equal to negative x squared. Try to observe. The sign of a here is positive, while here, your a here is negative. Okay? So doing the same thing, we have here, your x is negative 2, then the outcome of your y is negative 4. While your x is negative 1, then your y is negative 1. If x is 0, y is still be 0. If x is 1, then the value of y is negative 1. If x is 2, then y is equal to negative 4. Okay? So let's try to find out the graph of the two quadratic function. So we have here. So this is the graph of f of x is equal to x squared. Try to observe. Your f of x is equal to x squared opens up since your a is positive. And then your graph opens downward since your a is negative. Your g of x is equal to negative x squared is actually the reflection of your f of x is equal to x squared. The same as with this one. X squared is the reflection of g of x is equal to negative x squared. So their only difference is the sign. Okay? Next. How about if we're going to use a table of values to graph a quadratic equation? So that is the way of graphing a quadratic function. Also, use the fact that a parabola is symmetric because of that axis of symmetry. First, find the coordinate of the vertex and several points on one side of the vertex. Then, reflect the points across the axis of symmetry. For graphs of function of the form y equals ax raised to 2, the vertex is at the origin. Okay, so that is always at the origin. If your quadratic function is in this form, ax squared, therefore, the vertex is at the origin, 0 and 0. So your axis of symmetry there, which is always represented by x, is equal to 0. Okay? So let us have this one. Use a table of values to graph the quadratic function y is equal to 1/3 x raised to 2. Okay? So again, let us try to make a table of values. Choose values of x and then use them to find for the values of y. So we have here, what is the value of y if x is negative 2, negative 1, 0, 1, and then 2. Okay, let us try to solve. We have here, y is equal to 1/3. Your x is negative 2. So you have there 1/3. 2 times 2, that is 4. So you have 4/3. So the value of y is 4/3 when x is equal to 2. Okay, I'm sorry, negative 2, I should say. Next, what is the value of your y if x is negative 1? So we're just going to do the same thing. Y equals 1/3. Your x is negative 1 raised to 2. So 1/3. Negative 1 times negative 1, that is 1. So 1 times 1/3, that is still 1/3. That is 4/3. That is 1/3. How about 0? Y is equal to 1/3. The value of x is 0. So 0 times 1/3, that is still 0. Okay? So you have there 1/3 times 1, that is still 1/3. This will be 1/3. And how about this one? So 1/3 raised to multiplied by 2 raised to 2, so that is 4. Multiplied by 1/3, so that is equal to 4/3. So this will be 4/3. Try to observe. If your x is 0, then your y is 0. Try to observe here. If your x is negative 1, that is 1/3. If your x is 1, that is also 1/3. If x is negative 2, then y is equal to 4/3. If x is 2, y equals 4/3. Try to observe. They are the same in y. They are the same in y. Meaning to say, this one represents the vertex of the function. Okay? So, you have there already the value of, let us just erase this one, our computation. Okay? So, you now already know how to find for the value of y whenever you are given with the value of x. Okay? So, we have there. Let us now graph it. So, this is now the graph of the given function. Y is equal to 1/3 x. So, this is now the 1/3 x squared, I should say. This is now the graph. It is a parabola. This is 0, 0. If x is 1, y is 1/3. If x is 2, y is 4/3. So, this half represent the reflection. This is the reflection of the other side. Okay? Next. So let us have this one. Y is equal to negative 4x squared. So if you're going to make a table again, x is negative 2, negative 1, 0, 1, 2. So what will be the value of y if x is negative 2? So negative 2 times negative 2, that is positive 4, times negative 4, that is now negative 16. Of course, that is 0. If this is negative 16, negative 1 times negative 1, that is 1, times negative 4, that is negative 4. So that is 0. So meaning to say, this is also negative 4. And this is negative 16. Okay? Am I correct? Oh, what happened? Oh, sorry. Okay, so that is now the graph of the given quadratic function. Okay? Since your a is negative, then the graph opens downward. Okay? So we have here, let us try to discuss about the width of a quadratic function. So, it says here, when m, the absolute value of m, is less than the absolute value of n, the graph of y equals mx raised to n, raised to 2, I should say, is wider than the graph of y equals nx raised to 2. Okay? As we learned earlier, the sign of the coefficient of the x squared term tells the direction it opens. Okay? So if your a is positive, it opens upward. If your a is negative, it opens downward. Positive, it opens up, and negative, it opens down. That's what I have told you. Okay? So we have here. Let us try to compare the width of the three quadratic function. So we have here, the first quadratic function is y equals negative 4x squared. So since your a is negative, it opens downward. But try to observe the opening. How narrow or how wide the opening of those graphs. So we have here, this is the graph of y equals 1/4 x squared. It is very wide. And we have here the graph of x squared. This is what we call the parent function. Okay, let us try to identify. Your a here is equal to negative 4 on the first graph. Here, your a is 1/4, while your a here is equal to 1. This is your, what we call the parent function. Now, let us try to identify the widest of those three graphs. Of course, we have here this one. This is the widest. So what does it mean? If your a is 1/4, then that is the widest graph. How about here? Your a is negative 4, and it is the narrowest. What does it mean? Okay, it means to say that the smaller your a, the wider. The smaller your a is, the wider. We're talking about the absolute value, I'm sorry. 1/4, the absolute value of 1/4, that is still 1/4. What is the absolute value of negative 4? Then that is 4. Okay? So if your a, the absolute value of your a is greater than 1, then the graph is narrower. But if the absolute value of your a is less than 1, then the graph will be wider. Okay? So let us have this one. So, your a here is 1. Your a here on the first equation is 1. How about here? Your a is 2. This is greater, right? So, this is narrower than that of your parent function. Okay? So, how about here? This is your parent function. And this is, your a here is 1/2. This is less than 1, right? This is smaller. But then, it is expected that the graph will be wider. Can you follow? Again, your a is equal to 1 here. That is your parent function. So that is the normal graph of the parent function. If your a is less than 1, absolute value, the absolute value of 1 less than 1, then it is wider. If your a is greater than the absolute value, okay, is greater than 1, then the graph will be narrower. Okay? Oh, how about here? Let us try to compare. That is the parent function, right? And we have that 3x. Your a here is 3. What can you say? Is it narrower or wider? It is narrower. How about here? Your a here is 1/3. So this is less than 1, therefore it is wider. Can you follow?